Can I get that sharing option as well? In sharing option?
Yeah, you are already co-host.
Okay, share. Now you can see my desktop, right?
Yes, sir.
You can see my screen. So he already, Satish introduced me, but just these are 3-4 lines of boasting about me. Yeah, just 20 years of experience. Earlier worked with Tata, Society General, IBM. I started as a programmer, technical lead, application architect, management consultant. I was one among the first ITIL V3 expert certified in India. That's just boasting because my trainer told me you were the first batch in India. So I'm just saying for fun, right? I really don't know, but they told me you are the first. So I just put it. It is one of the toughest certification in IT. We all learn during, when we join IT companies. Every year there will be trainings and learning. So learnings never end in our life. And then we also give back, like not only to IT crowd, also to universities and other education institutes, and same as GrainEd, and that's why I'm here in GrainEd. Okay, and yeah, he already mentioned of 2 Malayalam novels published through Green Books. Maybe you haven't read. That's Deva Kanigagal and Mean Karanam Lolidem. If you know Malayalam, if you understand, you can try reading, and the translations might come later. And then some couple of English poem collections, Curiosity Part 1, Part 2, and Culture Part, all this, and a book on computer fundamentals. I'm still also refining further updates on that. That I got inspired from this session, GrainEd. So thanks to Satish for inviting me for for these knowledge sharing sessions as well. Sometimes that happens. And my other areas of interest: cinema, football, cricket, music. Okay, that's short about me. And we will move to the session part. Yeah, computer fundamentals. So if I ask you a blunt question, what is computer at the moment? Everyone use computer, everyone sitting in front of either a mobile or so if I ask you what is computer, what would be the first answer from from your head? Ridish or Navneet, somebody can answer that. We'll go that way in
computer, like we use computer for communication, for learning.
Yeah.
Like we use,
keep going.
And we use computer for calculations also.
Yeah. Navneet or Gada, keep saying something. Whatever you get into different, you have different answers.
Computer is used for storing and processing information.
Yeah.
Sir, also it's a machine which follows orders. Okay.
Yeah. All those answers are right? So computer, the word, it's Angelina, you want to tell something?
A computer is a device that helps us for communication.
Yeah. Computes, right? Compute. It's compute. Calculate. Yeah. So sometimes people say calculator, right? Big calculator. Yeah. And so there are different terminologies. Process information, as Manu said, process information, calculates. You all said, Angelina, Ridish said, communicates, make decisions. Yeah, make decision. How does all this happen? That's a magic inside that. So there are all these different synonyms, all this happens. Yeah. And so these are the sessions we will go through. Basic computer analogy, like, taking spirit from the way I have written my book, a bit of dramatized, like a story and all that, if you love that. So it's not like the other books which you see in your curriculum. It's slightly different approach. So everyone knows, I mean, what is computer, or you would have heard, okay, RAM, okay, ROM, and all that, okay, mainframe computer, that computer, big computer, microcomputer, all these terms you would have heard in your school text. So we are covering through that. It's exactly same, but in a slightly different perspective, so that we are bringing our own experience of, of last 20 years of what we have seen. Yeah, and we are hoping that will help you. Yeah. So binary numbers, you would have started learning that, right? Programming, you would have done electronic gates. If you're interested in electronics, you would have heard all this. Yeah, this is like that. There is some chip, IC integrated chips and all that. So we'll go through that all slowly, like a story. Yeah, we'll deep dive. Another perspective is like data movement. We all use internet. It's all, what is internet? Interconnected computers, right? And data is moving between all those nodes. We are discussing, and there is some data from here. It's going through sound and video. It's coming to you. So it's data movement, and somebody is controlling it. So data processing, data controlling, data storing. It's another perspective of saying what a computer is. Okay, because these days we all talk about data science, right? Data science, artificial intelligence, data mining. You hear all these terms in the current world, right? So that's why I gave you another picture. Now let's get into analogy. It may look a bit, silly, simple. What is it? We all know that, but still we need to, reinvent the wheel. We know that, this kind of comparison. So if I ask you what is a processor analogy with a human being, what would be your answer, Shreyash or Jayaprakash, Gada? Somebody can answer that. What would be an analogy to our human beings for a processor?
So our brain.
Exactly. CPU or processor, it's like brain. Now, what about keyboard, mic, mouse?
So a mouth.
Okay. Then look at that. Ears, right? You agree with me? Eyes, smell, what you see, what you hear, right? All that, you agree with me, right? And what is speaker, monitor? What is analogy?
So our actions like our output. Or
Yeah. So if I scold Manu, what will be Manu's expression and where it will be?
so in the face.
Exactly. That's a simple analogy, right? We are going to artificial intelligence. These the days of robots, and so we need to think this way. This is how things work. The same, networks inside our brain and all that. So the things you can relate every time. This is so it makes easier. It gives a different picture altogether, and it's easy to connect also. Yeah. And then you would have heard RAM. What is RAM? Anyone knows RAM?
The random access memory.
Random access memory. It is also known as primary memory. Anyone heard this name, primary memory? During your 10th computer, IT or whatever? I don't know what's your subject name. That's why I'm saying that way, generalized. So primary memory is another terminology used. Anyone come across that? You have to tell me yes or no. Somebody speak. That'll be easier for me than looking at chatting. If somebody says yes, no. Yeah. Primary memory is a term comfortable for you, or
Yes.
RAM?
So
Or is it
RAM is
RAM. Yeah, but I'm introducing this term primary memory in level 3. These are all terms you may read or you may come across in books. So you can say that it is RAM, random access memory. Or now to understand that better, how do we compare with the human beings? Is something stored in our near memory. How do you really compare that? How do you really compare that with our brain? For example, you're studying for an exam, say science exam, and then you're studying all those 10 different topics. It is loaded. Where it is loaded? It is loaded in your brain, and it is something similar to that, right? You have loaded all that like a page, right? So that you have exam next week, you studied all science in your head and all that. So that's the, and a book will be what? Like a hard disk. Everything is there in the book, but you have loaded something into your, isn't it? You agree with me? Yeah.
Yes, sir.
So there is something also called ROM. What is ROM? Read-only memory. Anyone can say some kind of analogy with human beings? Read-only memory. So it can't be changed, right? Read-only memory, something which can't be changed, right? So Ritish, your name, you can't change it. Of course, you can change, but you can't change that easily. Once it is done, it is there. Ritish is the name. And it is there in your head always, right? My name is Ritish. Or say our country name, India, or somebody is from United States. Those names doesn't change easily, though it can be changed, but it's like read-only memory. It's stamped forever. So that is kind of analogy we can have. Simple analogy. Read-only memory. It's burned into our head, right? From your childhood, Ritish or Sindhu or Gada, that name is stored into your head. It's anytime somebody asks you, oh, Ritish, that's mine. So it's burned into computer in this case, right? Some things is some kind of program is burned into the computer using some methodology. So that's burned memory, right? That is ROM. It can't be changed. There are these days EEPROM and all that. I'm not going to that at the moment. Just understand it in a pretty simple way. Yeah. And then, as I said, so when you're studying for exam, book would be a hard disk, right? Or it could be so if you move from one grade to another grade, there may be something on back of your head, but you can't reproduce it. It's there, right? You can call that also as a secondary memory, but it is kind of, you can't fetch it immediately. If in the context of an exam, you are preparing something for immediate. So if you are in the 10th grade, you are preparing for 10th grade exam. So that science part is there. You just loaded it. That's the. But you may be remembering other things, so you can say those is something like secondary memory. It is there, it's hard disk, or it is there in the book. If I go there and fetch it, I can still get it. So book is an external memory. So there are some terms: hard disk, secondary memory, external memory, level 4 memory. All these are different terminologies used alternatively, right? But it's all same. In some text it is used as external memory. Some people use it as hard disk. So that's why I'm using all that, because I really don't know in which part of the world which word is used. There are hundreds of books and all these use different terminologies, and I had to, in the first session I actually used one, then I realized some people call it as external memory, so I added all that synonyms. Yeah. So you can, in this context, a textbook is an external memory. So there are some classes, there is open book exam, so you can go there. It's there in the book. When a question comes, you go there and look into the books, you turn pages. This is where the exam is. So book is a secondary memory, external memory in that way. So there is a hard disk or there's an external memory in the computer or laptop. Or even in mobile, we use such things as small, kind of a chip, right? It's all those chips. Yeah. So all these are integrated circuits, IC chips. We will come to that later, but I'm saying that in case if you had, kind of these kind of words put into your head, right? I'm just using alternative names. Yeah. Now, as I said, these are all levels of memory. We are going through analogy. That's why I'm putting this level 1, level 2, level 3, level 4. So what is level 1? Level 1 is like register. Immediately, that's there in your head. Tuck, tuck, you get your name. If you calculate 10 plus 10, 20, that's there. If some of the things it's there in your head, you use your memory space quickly, right? Otherwise, you use, book, pen and all that, if there is a bigger number and all that. So something comes out of fast, that is register. Those things are required. That's like CPU register memory or memory address register. CPU memories. That's what it's called, right? Level 1 register. It's in the near to CPU. It's fast. It's quick. It's used for calculations. All those are called registers. In school, you have a register. Why do you use a register in your school? You get the idea. That's why. If you correlate with that, you understand that. Why do you have a register, a class register? Apart from school register, you have a class register, isn't it?
So to store the details of the student.
So what is class register? Class specific, right? And then you have arts register, you have a sports register, some schools, right? What is arts register? People may be attending arts competitions. Have you seen that? Or if you haven't seen, maybe your house leaders or maybe your school teachers, or I don't know how that system works in different schools. But have you heard such registers? Somebody can say yes, no, Gada?
Yes, it's a.
Okay, so there are different class registers, something for checking your specific subjects, something for art, something for sports. So all those are for quick references, quick, quick actions in your school. Same way in your brain, you have automatically you create something when you calculate something. And in computer, you call this as registers in the name of accumulator, program counter, right? Or in general address registers. Okay, these are all different purpose registers. I'll come to that. Now there is something also called cache memory. What is cache memory? In your terms, in your human terms, in our terms, what is so when you study something, what is cache memory? You are studying for science exam. What is cache memory in that context?
So the preference, the memory which we prefer more.
Pritish, okay, yeah. And Manu, you have some answer. What is cache memory in the context of, say, you are preparing for science exam next week, or you have science exam today? What would be cache memory in your context, Manu? In human
memory, a memory that can be registered in a quick amount of time. Yeah, quick amount of time, and you use that memory a lot.
Exactly. See that word? You use a memory a lot. So you know some of the questions potentially that may come for science exam. So you may go through that. So today morning you have science exam. So you're reading, oh, I need to look at all this, refresh. You have studied it yesterday. You have it, but then you go through that, right? So in the internet browser, you will see some of the sites you have seen several times, right? So then you click, it goes to that site faster. So that's cache memory, stored in the cache memory, similar to that. So it's a concept similar to that, like we go through for exams quickly, or these things may repeat for the exam. Some, not for all exams, but, sometimes you use that. Oh, this is something which we should remember. Fast is, or if you are going for a speech, say before today's session, I came here, I took it 3 months back. So again, for today, I need to prepare. How do I prepare? I just go through that part one more time. Oh, this is what I need to speak to you guys. That is why I'm doing that, just to bring that into our near-term memory. That's why cache. So I can reproduce it fast. That's the purpose. Fastest memory. You want to reproduce it fast, right? That's the reason why. It's called as cache memory, and the quick temporary fast one. Yeah. And then level 3, I already told you, that's my main memory. Yeah. And then level 4, secondary memory, that's external memory, which I have explained in the last part. So level 1 as 1, 2, 3, 4. Yeah. So in a diagrammatic way, you have a CPU. Inside CPU, what you are seeing? 3 register memories. This is near-term memories. You have to look at that box. Look at that box. Immediate memory, that's a quick one. And then there's a cache memory, there's a very fast, even before primary memory. So level 1, you have a level 2, and you have a level 3, and you have a level 4. So what is the difference between primary memory and secondary memory? Anybody can say just by meaning of it, but whatever you know by using laptop or any other desktop. Difference between level 3 and level 4, high level difference.
Primary memory is a memory you get directly from your brain, and the memory is inputted directly into your brain. And secondary memory is information that you get from a secondary source.
Yeah,
A book.
and it is stored, right? It is stored. Even if you switch off the computer, right? Primary memory, it will be lost. In the case of computer, if you switch off secondary hard disk, every details will be there. All those photos you have stored, it's there, right? So that's slight differences. That's why it's there. It's like in the book, it is there. It is written in the book. It is written in the hard disk. Magnetically, it is written there, hard coded, right? So other one during processing, all those memories, primary memory, level 1, level 2, level 3, it's used during the processing part. And level 4, it is stored, right? So that's where all these levels are. All these things are you have learned in your books, but I'm trying to put it in a slightly different ways, which because when you get into the higher grades or engineering, all these terms will bombard into your head, right? So that you get, this guy, one guy, old man talked long back, you'll get some kind of memory at that time if you're proceeding with IT or computer science. Okay. Now let's compare what is this accumulator, and there's something called accumulator register, right? So I already shown you actually. So if you want to add 78 plus 67, what do? 8 plus 7. You get what? 15, right? Then you put 5 there. You agree with me? Ritesh?
So can you repeat like your
If
voice
I
was
want to
not-
add two numbers, 78 plus 67 in my memory, in my head, immediately, spontaneously, what happens?
Sir,
8
I'll
plus-
remove the 8 and 7, then add 80 and 60.
So what happens? 8 plus 7, 15. And what
Yes,
is
sir.
carrying 1? Right?
Yeah, sure.
You
Yes, sir.
carry 1. So you put that 1 aside in your head, okay, 1, and then 10 plus 6, 13, plus 1, 14. That's how you get 145, right?
Yes, sir.
So during that process of calculation, right, you're doing that, and during that process, you have a temporary storage, right? So that is accumulator space during our calculation, isn't it? During our calculation, we use that some space 1, right? Just to add that, right? That's how accumulator is used in computer or in computing. Accumulator is a register used during this calculation process. Okay, you can correlate, right? You can correlate. In computer also,
Yes, sir.
similar space is used, and that's called as accumulator. And what is this red ribbon?
It's a bookmark.
Bookmark. And that's program counter. In program counter, in bookmark, what happens? That is the next page I need to read. So yesterday I have read and kept it. So tomorrow I need to read this page. That's bookmark. It's program counter in computer. That's the address of, what is that? Temporary place, address of next instruction. Address of next instruction. So I'm executing something. Now, where do I go and look in the RAM? So in the RAM, all you have programs. So next address. So 1, 2, 3. It's all stored as 0, 1, 2, 3 in address. So it goes, okay, first address 0, and then yeah, I pick that, load or add 78 or add 67, you add, or minus multiplication or whatever it is. So computer is a computing device. So there will be computing and commands. So I'm putting that into for you to understand. So program counter. So add 1, 0. So next address, and then next address, and next address, like a ribbon, like a next page. That is program counter. So there is a space for that in computer. That's called program counter register. Okay. Instruction register is where the encoded instruction, right? Like add, addition, or add 78 or add 67, that or add that part. You give that instruction, encoded instruction. That's where it's stored. That's instruction register. Okay. So these are 3 important registers. So when I say 3 important registers, is just conceptually. There may be n number of spaces. In computer, there will be n number of ALU, arithmetic logic units, means there will be n number of registers. I'm giving you one example, right? An example name. Okay, so instruction register means like this for you to visualize, okay, at this moment. Yeah. Now let's get into a bit more different visualization of this. Yeah. What is this RAM? Random access memory. So last time I was trying to explain, so I tried to picturize it with a bit of dynamic activity. If anyone has seen, for one person, I think I tell. So this is RAM. You can see, what do you see there in RAM? Address and value. What is there in address and value? Someone can read that? Abhirami? She's not speaking. Abhirami, what's there in the RAM? Random access memory. This is our RAM, primary memory in our computer. Abhirami can read that for a change. Let me see if you're listening or if you're reading this. Can you speak? What do you see in the address? What do you see in the value? I can't hear you. So Manu is speaking, Ridesh is speaking, two people. Gada, let me hear your sound.
Yes, sir.
Okay, so what is there in the RAM in this computer for the moment? I'm giving you a visualization. What is there in the RAM? Can you read out that?
Address value.
Address and value. What is there in the address? 0 to 15, isn't it?
Yes.
And what is there in the value?
Things loads, it's add 7, stores, it's M1, 25, 30.
Okay. Now, what are we going to do? You know, we are going to do a fetch, decode, execute. I'm going to show you live how computer works inside. How computer works. Okay. You have to be very careful, listen and observe this very carefully so that you understand in 1 minute. There is something called CPU clock. Have you heard this CPU clock? So
No,
for
sir.
the moment, it's like sending a pulse oscillator. It's a device like that. So you can think like a second, you know, just like tuck, 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 1 second, right? So if you read advertisements of computer, you will see 3.2 gigahertz processor computer, all this. Okay, so there is a clock with 3.2 gigahertz speed. Yeah. And what does it do? It send a signal, electric signal, like tuck, tuck, like 1 second, second, third second. But it's not in second, 1 by billionth of a second, right? Billion, 9 zeros, one after that 9 zeros. But for simplicity, I'm telling you 1, 2, 3, like that. But it's actually, how is that? 1 by billionth, BILLION, billion. That's the kind of speed these days we have, you know, the computers in the market, right? When we say 3.2 gigahertz. So this will generate, this is an oscillator, this generate a pulse, electric pulse, tuck, tuck, like this. And what happens then? What happens? These are registers, right? As I said, CPU registers. How does it work between CPU registers and RAM? So first you have program counter. What happens first for the first pulse? Tuck. Program counter is 0. What happens? Fetch, right? What does it fetch? Tell me, load 6, isn't it? What is program counter? Address of next instruction, which is, tell me, Manu. 0. What is there in the 0?
Zero's address leads you to the instruction register.
Load 6, yeah. So load 6, instruction register. And then what is there in 6? In the RAM, what is there in the 6? Look at that. Load means load 6. Load is the instruction, 6 is the address. Okay. So load 6 means it's a random, right? Random access. Randomly it is going to 6th location. Can you see that? That's why it's called random access memory. So load 6. Instruction is load 6. Tuck. This is an assembly language. So for you to understand, it's all binary, but for you to understand, I'm giving it as assembly language, a language in between. Load 6. What is 6? Can you tell me the number? In the RAM, 6th
20.
location? That is
Maybe
20, right?
No, 20.
20. Can you see that in RAM also? You're observing that? 5 is
Yes, sir.
30, 5 is 36 is 20, right? And then what happens to program status register? The program is running, then it becomes 1. If a program is running, it becomes 1. Otherwise, it is 0. Okay. Now let's fetch 1 execute, fetch execute cycle is over. 1, that is 1 fetch decode execute. Fetch decode execute. 0 load 6, 6 is 20, and then as that cycle is over. And then what is program counter now? Can someone say what is there in the program counter? In the RAM? So tell me what is program counter value at the moment?
Sir, add 7.
Add 7. So what will happen to add 7 now? If I say tick, what will happen? Where it will go?
So to the program counter.
Add 7. Where add 7 will go? Program counter is the address of next location, which is 1. Where does add 7 go? It's instruction, right?
We'll go to the value 50.
So see this, add 7, where does it go? Isn't it? It goes to add 7, right? Instruction register. And now, what is next? What is next? Next step. What will happen? I want you to tell me now. I showed you first part. So when add 7 is done, what will happen as a next step?
So I'll go to the next one.
What is add? Add and 7. What is there in the 7? What is the value in the 7? RAM?
The value is 10.
Value is 10. So what will happen if I say 1 tick? Isn't it? 20 plus 10. You got it?
30. So, but why is it accumulating to 10 then?
So it is
Like, why is
fetching.
it 10?
So go to what is there in the RAM?
So RAM 7 is 10. Oh, okay.
Okay, so that's why I wanted you to tell me that. So load 6. So this is 0. Program counter 0. That is load 6. Okay. Load 6 is 20. That is loaded into accumulator. And then the next address of next location, that is you turned it program counter 1. And in 1 you have add 7. And add 7 is nothing but in the 7, what do you have? 10. And what do you have in the accumulator? Arithmetic logic unit register, 20 plus 10, it becomes 30. Okay. You understand? You got it?
Yes,
Everybody
sir.
understood the cycle? It's a simple cycle. So I try to put it in a simple, kind of load program. Basically, everything is written. All these things are in binary numbers. Okay, I'm giving this for explanation purpose. To humanly explanation. I mean, whatever that makes it easier for you to understand. But even this is sufficiently complex at this stage. If it is actual program, I'm telling you only very simple stuff of adding. So it looks very easy for you to understand the fetch, decode, execute cycle. Then what happens? What is the next program counter? So add 7, 30. Okay, what is next program counter?
2.
2. Okay, and then what will happen? If I
Store
click
6.
store 6, so store 6 means what?
2.
Store 6 means
2.
we have to store what do we have to store? What did actually what was our execution? We added 20 plus 10, right? We
Yes.
added two values in the 6th and 7th location, 20 plus 10, and we got 30. And what are we saying? Store 6. So store 6, I know you don't know the actual meaning of it, but here in the context, as an explanation, I'm telling you, store 6, it go and store whatever we got in the accumulator. It is written in RAM now. So one cycle is over. One calculation store cycle is over. Okay. You have a load, you have an add, and then you have stored. Okay. This is how that sequence happens. Fetch, decode, then execute. Yeah. So now it is 30. We stored 30. So earlier, what was it? 20 in the location. And when we got this calculation 20 plus 10, 30, we stored 30 in that location. That is store 6 instruction register. What is instruction register? It is execution, the encoding, right? The encoded stuff. So that meaning is actually executed. Store 6 in the context, it means store the value of accumulator in the 6th location of the RAM. Okay, that is the meaning of it. Now, what is the next instruction? What is next instruction? Program counter. Here, what is next program counter? You tell me. What is next program counter? What is the value of program counter?
3.
3.
3.
What is there in 3 and what is the meaning of 3? Can someone
Jump
assume it?
1. Jump 1.
So what would be the meaning of it? Assume it.
Like we have to skip one number. Right?
No, in this context, it is going back to location 1. Okay. So I know you don't know the meaning of it, but it's okay. Currently, I mean, for this program, meaning is go back to location 1. Okay. In your program, computer program, you write programs for 1 to 5, or while something count becomes or less than equal to 100. You will write all those loops, right? Here, go back to location 1. That is the meaning of it. So what happens in the program counter? It goes to 3. What is there in the 3? Jump 1. Okay. And what is there in the jump 1? Add 7. And what happens then?
Then accumulator will become 20.
Add 7. Think about it. Add 7.
So then it will become 40. 40.
Accumulator will become 40. Correct. Exactly. Now you got the cycle. Okay.
So like even though like there is jump 1, then even though it comes add 7, we'll have to add only, right? Not subtract, right?
Yeah, only whatever. It's a program in a loop. When it comes to jump, it goes back to 1. Again, it's add. What happens? 2. Store 6. What is stored in 6? Look at that.
Store in 6 is 40.
What is 40? From accumulator, isn't it?
Yes, sir.
And it goes on. Now, what will happen if I again click? I haven't written anything. What will happen if I again click program counter? Becomes what? You tell me now.
3.
And then jump 1. What happens then?
We go back to add
Add
7.
Add 7.
And then what happens? Add 10 and goes to accumulator.
50.
And that goes right back to RAM. And then this program loop will continue. This is how register and RAM works together. Okay. Now you got the cycle.
Yes, sir.
Okay. Now let me ask you, have you studied this similar cycle before in your high school? Similar, something similar? or only definitions? Let me ask that. In your computer book.
No, sir, I haven't studied.
Vinayak studied.
Yeah. No, I haven't studied.
You haven't. Okay.
Yeah.
Anyone? I want to know this. Basically, if someone studied, so that I get an idea of to speak around that. That's why I'm asking. Okay. If it is totally new to you, then fine. But if something similar you have learned, then it makes sense. That's why I want to explain that way. Yeah. Okay. So that's how computer register and RAM. What is that? Primary memory, level 1 and level 2. So this is level 1 memory, the left part. Left part is level 1 memory, and right part is level 2 memory. And this works like this. And finally, writing back to hard disk, that is a different thing. Okay, and cache I have not shown here. We'll come to that later. All that, but for simple kind of understanding, this is good enough, right? A CPU processor and a RAM. Okay. Now, this is a game. We have 10 more minutes. If someone wants to play a game, we can do that with our memory also. So whatever I explained, right? There is a game. How many of you have seen this kind of rhyming game? One run, two sue, memorizing number, the objects related to number, memorizing. Have you played this? Anyone?
No.
This is analogy. This is analogy. Same way I have done this memory address registers, right? CPU memory address register, same way we have in our brain like this. We can do that. So if we study this, can someone repeat after me? 1 to 10. One run. All of you. Switch on the mic and study this like a nursery school.
Root tree.
Yeah, just by heart it. One run, two sue, three tree. Like this, you by heart it. Have you seen people showing with the shows remembering 500 objects in memory and reproducing it randomly, tuck like this in television? World record 500 objects. Have you seen that shows?
No, sir.
How many of you have seen show something similar to that? 500 objects, memorizing and reproducing all of them randomly, sequentially, reverse, front, back, all that. After saying, in a television, I have seen some shows. So I would like to know if you have seen. You can learn that, and you can do it from tomorrow onwards, and surprise your friends. Remembering 100 objects and reproducing it, tuck, just like this. Anyone seen that?
Yes, sir.
Who said yes?
Sir Navneet.
Okay, Navneet has seen that. Manu, what about Manu?
No, I haven't.
You haven't. Angelina?
No, sir. I haven't watched.
So like our LKG, UKG class, we can go back to the rhyming. So everybody shout, right? Shout. Repeat after me. One run.
One run.
One run, two sue.
Two
Run, two sue.
Three
Five
tree,
high,
four
six
door. Five high,
Three,
five high.
Heaven.
four door, five high,
Nine wine.
5,
6 weeks,
7,
Six,
7,
six,
seven,
six,
eight,
six,
eight,
seven,
eight,
heaven, seven, heaven, seven,
eight,
heaven,
five.
seven, heaven,
seven,
like that.
heaven.
Eight gate, nine wine, like that. You say it loudly so that it is there in your head. I mean, like our nursery class. One run, two sue, like the way I say. Three, four door. It has to be so fast. Like CPU register, tuck, you have to get that immediately, that picture. And remember that picture also. One run, somebody is running in Olympics, right? One run, that Olympics stadium, somebody is running, in a 6 track Olympic stadium. One run. Imagine that picture. Okay, one run. Imagine that picture. One run, Olympic stadium. Somebody is running. One run, two sue, three tree. Sue. It can be any sue. What you know, but I have given you a picture for easiness. Two sue. It could be you, right? You are giving something to elephant. Two sue, three tree. It can be same tree or a tree in front of your house. Okay, three tree, four door, five high. Okay. A door in maybe in front of your house. 6 weeks, 6 weeks, 7 heaven, 7 heaven, 8 gate, 8 gate, 9 wine, 10 den. Everybody by hearted, somebody can tell blindly this. Repeat.
So can I
1 to
try?
10 without looking at, without looking at. Somebody can say this 1 to 10.
Sir, I can try. So 1 run,
Yeah, tell me.
2 zoo,
Yeah,
3 tree,
yeah,
4 door,
yeah,
5 hive,
yeah,
6 wicks,
yeah,
7 heaven,
yeah,
8 gate,
yeah.
9 wine, and 10 den.
Yeah, it has to be very fast, like this. It has to be very fast. So you have to repeat this. 1 run, 2 zoo, 3 tree, 4 door, 5 high, 6 6, 6 weeks, 7 heaven, 8 gate, 9 wine, 10 den, like this. 1 run, 2 zoo, 3 tree, 4 door, 5 high, 6 weeks, 7 heaven. That should be the speed, like our computer CPU. That CPU register, I want to compare that. I mean, it's like one, the memory address register, like, you know, program counter. Tuck, tuck, yeah, this is 1. And then what happens in the RAM? Oh, you have 1 and then run. Oh, it's Olympic Stadium. Yeah, so that's in the RAM. There is 1 person running that, right? That's a picture you have. So you have an Olympic Stadium. When I say 1, when I say 1, you have a run an Olympic Stadium. Somebody is running. You picturize that.
Yes, sir. Right.
Okay, now I'm asking you to store an object. Okay, I'm asking you to store an object. Yeah, in that Olympic Stadium, somebody is running, and the object you should store in that. So that person is having some torch. With a torch, he is running, right? And you can store, say, a ceiling fan. Okay, a ceiling fan. You can store a ceiling fan instead of torch. So this person is running with a ceiling fan in his hand, okay, in the Olympic Stadium. Everyone store that object in that Olympic Stadium. Yeah, somebody's running with a ceiling fan. You stored it.
Yes, sir.
Second, it's a shoe. You can imagine shoe, you know, and you can say you have a watch. Okay, you put this watch. Picturize that you are giving gift of this watch to this elephant, maybe this elephant or in the zoo, you know, and I'm giving this watch. This is the watch is the object you should remember. Yeah. Okay. You remembered second object
Yes,
is
sir.
watch.
Yes,
So
sir.
that is associated with zoo. You are giving watch to elephant. And 3 tree, right? And that is mobile phone. You are trying to remember associated with 3 tree mobile phone. So there is a tree in front of my house. I'm remembering it as, okay, mobile phones hanging from telephone, hanging from the tree. Okay, and the mobile phones are falling. So that's the imagination I have. Okay, 4 door. Okay, I have I have a door nearby, so I'll remember that way. And a television.
So what is for 4?
4 is television. Okay, so when I open the door, I can see a 45-inch or 50-inch television immediately, and I got surprised. And that is a story you should remember. So see, you store TV. Beehive, hive. 5, you can store same. What else? Something easier. I want to give you something easier. A purse. Okay, a money purse. A money purse like this. Okay, so a purse, and then the beehive, purse is falling down. Money is falling down. From a beehive, instead of honey, it's a purse. The money or money purse is falling down. That's easier for you to imagine. 6 is Wix, right? 6, you can give it as remote control. Remote control. This is the object you should remember. So when you open Wix, you have headache, and immediately you are getting a remote control. And when you got remote control, your headache is over, right? You imagine the story like that. Remote control. Okay. 7 heaven. Any heaven, you know, I just put a picture like this. The heaven is some, in stories, this is how you given. So, okay. Pen. You have a ball pen. This yellow pen. This yellow pen, or any pen you have, a yellow pen, and you are giving object pen in seventh location, heaven. In the heaven story, you associate with pen. 8, gate. The gate may be in front of your house, maybe or this gate. You can give football. Okay. Football, store that. So 2 big footballs on that gate. 9 is wine. If you don't drink, maybe your father's drinking wine, and you are giving, pouring on to his glass. And instead of wine, what is going there, right? It's basically okay, shaving cream. Instead of wine, it is shaving cream. He was expecting wine, and then it was shaving cream. And he was surprised, why you're putting shaving cream in this wine glass, right? And 10 is den, right? 10 den. So lion, you can lion's cage, you can see that. So lion is okay, maybe table. Lion is sitting on top of a table. It's not actual zoo. So lion is sitting on top of a table, big table. You put table as an object. Okay. Everybody try to store this. Remember this? Can someone
Yes, sir.
reproduce now all those 10 numbers?
Sir, I can. Like,
10 objects. Yeah.
so the first one is ceiling fan. The second is watch.
Yeah.
The third is phone. The
Yeah.
fourth is TV. The fifth is purse.
Yeah.
The sixth is remote control. Seventh is pen.
Yeah.
Eighth is football, and ninth is shaving cream. 10 is table.
Okay. So you are able to reproduce, not writing it in paper, right?
Sir, I don't have it.
Okay. But this is how it is. Now, if I ask you tomorrow also, you can reproduce it, right? Now, if you compare with our program registers in this case, right? Program counter, there you have 1, and then you have a run, a rhyming sequence. Then, and with that rhyme, immediately you are remembering certain area, right? That's a memory space in the human context in analogy. And you're fetching an object instead of a value, right? Exactly like this, right? So our brain, our school days when we study, we all say, don't by heart, right? But logically link. When you learn science, if you're passionate, if you understand fundamentals, if you understand computer science fundamentals, if you don't understand, you will by heart. Poems be by heart, because that's the easiest thing. Rhymes be by heart, that is easier to reproduce. There are certain things we by heart. Okay. Music, some songs, it comes to us. It's because it's easy. We can reproduce rhyming sequence and all that. But then when it comes to technology, science, all that we learn logically, it's same exactly like this. These are all labels, right? These are all labels in our memory or memory location. So if I ask you what is computer, you are reproducing it from your memory exactly like computer. That's the beauty of it. There is a memory location in your memory, that's computer, and there is something written in your head that computer is a processing something, computer is data processor, computer is so and so. That's what exactly happening, right? That's why I want to tell you, analogy of a brain, register, CPU, RAM, this all same, the whole same story. Now, if you don't believe, I'm telling you, even after 10 days, you can reproduce all these objects if you have properly recorded it. Maybe 10 days at least, bare minimum. Unless you overwrite it in the same story. You will remember, I'm telling you. Not just 5. If you learn 500, you will learn. Now you need to practice it, of course. This is just a game. This is just a game for demo. Okay? You agree with me?
Yes, sir.
Okay. And you can say reverse also in this case, but not in the case of computer. In this case, we can say reverse. Yeah. Now, we have completed 1 hour. There's a couple more slides. Can we go a quick for, and we take 5 minutes, Sadish?
Oh yeah, we can check the students.
Can we take 5 minutes just to? You tell me if you are not free, I'll close it today. I'll take 5 more minutes or 5 max 10.
So you can take it.
Okay. Now you understood what is this Wix coming here? I don't know, maybe I have put it strongly. What happens when you write a computer program? Yeah. This is your hello computer program. A simple one-line program. Anyone written a program like this? Gada?
But I have like when I was learning this Python.
Python. Okay, you have written Python. This is something. This I don't know. Maybe C or some C. Yeah, maybe C. Yes. So in C language, there is a command like this. Okay. And there is something called compiler. Anyone heard this compiler? This is our program. What is compiler? If someone knows, can tell that.
So compiler is a kind of translator which takes up which takes big paragraphs and translates it at the same time.
Okay.
Kind of a large scale translator.
Yeah. Program converts program into machine language, the program which computer understands. Right. In this case, compiler is a program that converts into machine language. What is machine language? 1010 binary numbers. Right. Binary numbers is basically computer understands binary language. So compile is a program that converts our actual C program, Python program, whatever program you're doing, basic or C++ or Java, into machine language. Yeah. So if you are using Windows operating system, executable, whatever you want to execute, it's stored in a folder, right, in hard disk. In the name, what? Hello game.exe. Okay, you agree with me? All of you agree with the sequence? Yes or no?
Yes.
And then what happens? What happens when you start a game or you are starting Zoom application? Zoom is basically an application, or a game is an application. What happens when you start? You click on a game, right? You click on that Zoom link. You click on an application. So you click on that. What happens? It goes to that location, right? In Windows, it goes to that C whatever folder directory. It goes to that, and what does it? It reads properties, right? It reads properties and path. You have seen this something like this. So my Python hello. My Python is the folder that directory. It goes. It reads properties, and what happens? It loads into the main memory in binary language, ones and zeros. Yeah, loaded into main memory, like we load our science subject before exam. It is loaded into main memory, all those binary language, like pages to read for the program, for the game. Right? You agree with me? This is sequence. And then game opened. In this case, this is game, right? It's open. The other Zoom application or whatever. You click, it reads properties from the directory and it loads into the main memory, like in a binary language, and the game is opened. Okay, that's a simple cycle. Yeah.
So like, can you repeat what you told? My internet connection is unstable right now.
Okay, so what happens? Where did you lost the connection? I mean, is it here?
Like after the Python, like you told, right? After we start up that application, we clicked again after that.
Okay, have you seen this?
Next, sir. Yes, sir.
Yeah.
Next.
So you click on the application, you click on that game or an application, whatever, whatever name you have stored, and then it reads that properties from the path, right? So for example, this is my folder. I have put my Python as folder. Okay. The hello is the program. Okay. In that hello, there will be properties. So when you click, what happens when you click? When you click a Zoom link, what happens? Zoom, it goes to somewhere it is stored, right? Somewhere in your machine it is stored. So it reads that properties. Okay. Once it is reads that property, that program is loaded into your, in the case of human, it is loaded in your memories. In the case of computer program, it is main memory. It is loaded in binary language, machine language, right? I showed you actually load 6, load 7, add 7, all that. that is the way, for explanation purpose. But what actually it is binary language, 1 and 0, right? Computer understands binary language 1 and 0. We'll come to that in the next session. For easy communication, I showed you as add 7, load 6, store 7, all that, right? This is how it is loaded, that cycle, yeah? And then it is loaded into main memory, application open. And then what happens when you close the application? Unload it from RAM, you throw it. Your science exam is over. Okay, forget it. Now next is mathematics. Now science, I don't need to remember. So tomorrow is mathematics, so I need to study. Or load all mathematics. Like that, load, unload everything from RAM. So application is unloaded. So it is there in the hard disk. It is unloaded from the RAM. So this is the interaction between level 4 and level 3 memory. Hard disk and RAM. It is loading from hard disk, external memory into the RAM. Earlier, what did we say? Register and primary memory. Here, what we are saying, from hard external memory into the RAM, and then we play the game and then close, unload it. This is a sequence, right? So all we were saying is, initially we said between primary memory and register. Now we are saying secondary memory to main memory, loading it from book, science book to our memory. You understand? 4 types. So all I'm saying is 4 types of memories. That's it. So if we go back, I run it in 2 minutes. All this, right? That memory part, it's what I covered is this from this slide I will take. I think then quickly I will tell you. All I was trying to tell you is this 4 types of memory, right? Inside CPU you have registers, and then you have cache memory, and then you have primary memory, and then you have secondary memory, which you call external hard disk. Yeah, external or hard disk. And then what we were saying, what is the analogy between this, right? Like a book mark or a accumulator, like a temporary store. And then the fetch execute during running of the program, right? When you run the program, what happens inside that? When you calculate, what happens inside that between registers and RAM, right? A clock tick happens, a oscillator, a tick, it goes like this. Program counter, address of next location, 0. Program counter means what is that in the book? It is bookmark. Here it is address of next location. It is load 6. Instruction register, execute that instruction, and it is 20 is loaded from location 6, and then goes program counter 1, and then goes add 7, then goes 30, and then store into the location 6, store into location 6, and then repeat. Program counter, go back to 1, and then add 7, and then it goes back and store in location 6 of the RAM. So this is between register and RAM, and then we compared it with a beautiful game, and you reproduced it very fast. Comparing with the rhyme, it is similar to this address registers, CPU registers analogy game. And then what happens when you write a computer program? We compiled and put into hard disk, right? Hello game is hard disk. It is theirs. It is stored permanently, right? But when you run it, what happens? When you run it, it is loaded back into RAM. It is where the pages of this program, this game is loaded in as binary language.
Sir,
it's executed. Yeah, tell me.
what happens when the RAM is full?
What happens?
When the RAM is full?
When RAM is full, then it is difficult. I mean, sometimes hanging happens. That's machine sometimes hangs if you have load too much into that. But then processor uses certain technology to unload the parts which is not in use. So always it will try to free up some space. Okay, if it is not, then it will be hanged. That's why sometimes you see some your machines getting hanged because you open so many windows. You'll keep on opening so many windows. What will happen? It all will load into the memory, small RAM. If the RAM is small, it all will try to load, and then it will try to get that memory space, and then it fails. That's why you close certain applications, and what happens? It is unloaded from RAM. You understood? That's a very good question. That happens in your real life, right? When you open too many windows, too many games or big games, right? And there are processors to manage it, to remove the unused memory or to use unused memory. But if it goes beyond, if you click too much, it goes hand. Even processor don't understand where it, it should go. All that happens. So you have to close applications if you are not using it. So that's good for your performance of your computer or mobile, or you clean up in between. You clean up your cache memory, all that, right? You have to do that, once in a week or whatever, depending upon the size of games you play. Okay.
So can we increase RAM size also?
Yeah, that's depending upon computer configuration. Some computers will have that facility. It is depending upon the fundamental configuration of laptop or mobile or whatever they have provided. So the manufacturer will tell you up to this much you can expand the memory. But for ideal optimal performance, there may be some guidelines given by Intel, Pentium, or AMD manufacturers. They'll give some optimal performances, right? With this memory, it will be optimal. There will be some guidelines. It is better to go with the guidelines. Technically, or maybe processor guys will give you, okay, you can go up to this. But yeah, you have to see certain levels beyond some stage, and the way computer industry has grown and the performances, applications. So after every 3-4 years, this RAM size and processor speed, all these things are going on like a race, right? And the demand of computing is also going up almost every day. So all I will tell you is maybe something which you were using a game to play the game 5 years back, may not be good enough for today's game, right? You may be having such big games where you need to have some powerful computers, powerful desktops or laptops. There are specific computers built only for games or movie making and all that, because it demands a lot of processing capabilities and memories. Yeah, that's a good question. Yeah. Any other questions at the moment? Because I'll come to that binary numbers tomorrow. I'm done with the subject today.